Ever since the COVID pandemic, people have shown increasing interest in food that benefits their immunity, work efficiency, and mental state. We designed and developed Omega Meal, a restaurant searching, filtering, and saving application that helps people track restaurants that search healthy plates. We incorporated a React front-end and multiple AWS services, including Cognito, S3, DynamoDB, Lambda, SageMaker, CloudFront, API Gateway, and OpenSearch. With Omega Meal, a user can search restaurants based on cuisine types and price filters. They can also keep track of their liked restaurants through the favorite list functionality. The app also allows users to share and follow each other's favorite restaurants, simply by searching one's user ID. Finally, we have an AI backend that intelligently assigns a health score to each restaurant to help our users choose more wisely. With this design, we're aiming to build a community of healthy eaters around our application.
Our user interact with the front-end website and noted that we set up CloudFront distribution to host our website on our secure domain and use Amazon Certificate Manager to manage the SSL certificate. When user first log in, he will be redirected to Cognito to sign up. After that, the user can log in with the account and password. We have the three databases shown in the middle. Restaurant, the data is collected from the Yelp API. Favorite list is to store users' favorite restaurant. The last one is follow. The data structure is a key value store. The key is the user, and the value is his followers. For the Lambda function, with the price filter and cuisine and rating, we can search from OpenSearch to return a list of restaurants that match those filters. The fourth one is to fetch the current user's favorite list. We also provide additional feature to manage users' favorite list. Last but not least, we have machine learning model hosted on SageMaker.
I want to introduce one of the core API in our program which performs search function. The input are cuisine, price level, and rating. We will feed these arguments into OpenSearch. Then OpenSearch will return a list of RID meet these requirements. Afterwards, we will use this RID to index the restaurant DynamoDB table to retrieve detailed information of the restaurants. Second API is get user favorite list. Input is access token. Based on the token, we can get a user ID, which is the user email. We will use the email to index favorite list table and get a list of RID. Afterward, we will use these RIDs to index the restaurant table to get a detailed version of restaurants. We also have add and remove restaurant from favorite list. For these two API, input is access token and RID. We will transfer access token into UID and use the UID to get a favorite list. Then we will remove or add a RID in the favorite list. The get method of favorite list resource returns all the favorite lists that the user followed with the detail of restaurant. First, it will get UID from access token in headers by Cognito. Then use the UID to retrieve following UID list from the following table. After that, we use these UIDs to retrieve the restaurants for each user in his or her following list. Finally, we leverage those RIDs to get the detailed information of those restaurants from the restaurant table. The put method of favorite list view allows the login user to follow another user by a given user ID. The last API is the get method of health resource. It infers the health score of given restaurant. First, it takes the restaurant ID from the query to get the image URL from the restaurant table. Then inference the image by the endpoint of SageMaker, which returns the probability for what the food is. After that, we product the probability with the table and the healthy score for each class of the food to get the expected score of the image. Moreover, we combine it with the human label data and input both of them to our scoring algorithm.
That wraps up our presentation. We thank you for your time.